Solution TV, learning made easy, come and see. Chemistry, math, Kiswahili. We like the spark to Nawasha Akili. Online Solution TV, from Bome to the world we teach free. Click, watch, grown up mystery. With the future ni sisi tayari. Online
Good morning, good evening, good afternoon. How are you doing there wherever you are? In this video, I want to bring you salts. Salts is a very important topic. So I will define what is a salt. So this video has been divided into three. Number one, we will define a salt. Then I will give you types of salts. Then I will do solubility with you. Salts which are soluble and those that are insoluble. Then finally, we will prepare salts. Those that are soluble, they have their own way of preparing them. Insoluble salts also have their own procedure. Welcome and let's learn together. My name is Teacher David. Online Solution TV, giving you always the best. Nothing but the best. First, I want to define what a salt is, and once we understand a salt, and then we will be able to understand how important this topic is. What is a salt? A simple definition, we know that a salt is a substance. A salt is a substance that is formed when the hydrogen ion or ions in an acid hydrogen ions in acid are either wholly or partially replaced by a positive ion. That is the definition of a salt. For somebody could be wondering, now what does this mean? Let me give you an example of what a salt is. Take an example of a reaction between a base and an acid. For example, sodium hydroxide plus, let me take sulfuric acid this is a base plus an acid. What do we get? We get a salt plus water, neutral substances. We get a salt plus water. So which salt do you expect here? It is sodium sulfate. Sodium sulfate plus water. What is this? A salt, and this is water. Now what is a salt? A salt is a substance that is formed when the hydrogen ions in the acid, what is this? Is the acid, and this is the base. Now look at this acid. The hydrogen ions in the acid has been replaced. Is it to replace or displace? Has been displaced. So the cation from the sodium ion has displaced or has replaced the hydrogen ions in the acid. So when the positive ion replaces the hydrogen ion in an acid, a salt is formed. Very correct. Even take an example, even a metal, sodium plus HCl. What do we form? We form sodium chloride. This is a metal plus hydrogen gas. This one is a metal
This one is an acid, and this one is a salt. This one is a gas. We are concerned about the salt because we are talking about salts. The salt sodium chloride, how was it formed? What is a salt? It's a substance that is formed when the hydrogen ions in the acid are wholly or partially replaced by a positive ion. So here the positive ion is, remember, sodium. Sodium is positively charged. Let me dismantle this one. Hydrogen ions plus chloride ions. So this hydrogen, positive ion here displaces the hydrogen ion in the acid. So this sodium attaches itself to chlorine and they form the salt. So we are going to form sodium chloride. So the hydrogen ions in the acid has been displaced, has been replaced by the sodium ion, which is positively charged, and then a salt is formed. So a salt is a substance that is formed when the hydrogen ions in an acid are wholly or partially replaced by a positive ion. We have different types of salts. We have actually 4 types of salts. We have number 1, the normal salt. A normal salt is a salt which does not contain any replaceable hydrogen in it. Salts such as sodium chloride, sodium sulfate, calcium nitrate, all of these are called normal salt because they do not contain the replaceable hydrogen in them. They don't have replaceable hydrogen in them, so they are called normal salt. Number 2, we have acid salts. It is important for you to know that acid salt, these are the salts which contain replaceable hydrogen in them. So they contain hydrogen in them. An example of this is sodium hydrogen carbonate. Sodium hydrogen carbonate is an acid salt because it contains a replaceable hydrogen in it. Another example is potassium hydrogen carbonate. Potassium hydrogen, or even carbonate or sulfate. Also this one contains the replaceable, therefore this one called acid salt. They are called acid salts. Number 3, we have basic salts. What are the basic salts? These are salts that contain hydroxyl ions in them, OH negative. So those salts that contain hydroxyl ions in them, they are called basic salts. An example, e.g., we can give zinc, basic zinc chloride. This one is called basic zinc chloride. That's one pattern example. And then last, number 4 is the double salts. Double salt is a salt in which there are 2 different anions and cations. One salt contains it can have 2 cations in it and 2 different anions in it. An example of a double salt, you can talk about potassium aluminum sulfate. This one is called potassium aluminum. This is potassium, this aluminum, and then sulfate. That one is a double salt. But my major aim is to enable you to know the types of salts. So it is important to know types of salt and at least one example for each. The next thing I want to talk about is the solubility. Solubility of salts. Now this is where you really need to understand solubility of salts. Salts that are soluble in water and the salts which are insoluble in water, it is important for you to understand. But before we talk about the solubility of salts, it is important for you to know the types of salts we have. We have salts that we call nitrates. Number one, we have salt that we call nitrates. Example is calcium nitrate, potassium nitrate, sodium. Type of salt number two is the chlorides. So when I'm talking about chlorides, you should know examples of chloride. We have magnesium chloride, zinc chloride, we have sodium chloride, etc. So chloride is an example. These are examples of chlorides. And then number three, we have carbonates. We have magnesium carbonate, we have sodium carbonate, etc. But every metal carbonate, every metal at least has each of every salt I'm talking about, except some metals which does not have some salts, but it is few of them, very few of them. Number four, lastly, is the sulfates. Sulfates. So sulfates, we have several of them. You can even start from copper sulfate. We have zinc sulfate, and it is so many of them, etc. There are so many other sulfates. So once we have now known that we have four types of or different salts, we have four different salts: nitrates, chlorides, carbonates, and sulfates. So for you to mention a nitrate, you put the metal in front: magnesium nitrate, calcium nitrate, potassium nitrate, sodium chloride, zinc chloride, like that, sodium carbonate, etc. Now we will go straight away and see the salts which are soluble in water and those that are not soluble in water. Very important in practicals and answering general questions in chemistry. The question is, are all these salts we have mentioned soluble in water? No, not all of them are soluble in water. So we will start with nitrates. All nitrates, all of them, all nitrates dissolved in water are soluble in water. So all of them, when you dissolve them in water, they form a soluble salt. Chlorides. Are all chlorides soluble in water? No. All of them, all chlorides are soluble in water, except, here I want you to mark that, except the chloride of silver, silver chloride, comma, lead chloride, the chloride of lead or lead, are insoluble in water. So lead chloride, silver chloride, they don't dissolve in water. They form a white precipitate when you put them in water. But the difference between lead chloride and silver chloride is that lead chloride dissolves in hot water. When you warm the water, or when you warm the white precipitate of this, it will dissolve to form a colorless solution. Therefore, lead chloride is soluble in hot or warm water. Very important. So all chlorides, they are soluble. They dissolve in water, forming a colorless solution, except silver chloride and lead chloride. Sulfates. All sulfates are soluble in water, except, mark this, except which one and which one? Except lead sulfate, barium sulfate. These two are completely insoluble in water, but calcium sulfate is insoluble in cold water. It's so insoluble, but it is just slightly. So this one is slightly soluble. But if you dissolve calcium sulfate in water, it forms a white precipitate, but it is slightly dissolved. But so we say calcium sulfate, lead sulfate, barium sulfate are insoluble in water, because the water, if you dissolve this one, you will see some milk. So if it is milky, then that one is not a colorless solution. So calcium sulfate, lead sulfate, and barium sulfate, they form white precipitate. It means they are insoluble in water. Finally, the carbonates. All carbonates are insoluble, meaning that all carbonates do not dissolve. They don't dissolve in water. Instead, they form white precipitate. They form milky solution. They don't deform. All of them, they are insoluble, except. That's why I told you the word except. Those that are exceptions are the most important you want to, because they are the one that are being tested. So all carbonates are insoluble except the carbonates of potassium carbonate, sodium carbonate, and ammonium carbonate. These three, ammonium carbonate, sodium carbonate, potassium carbonate, all of these three are soluble. They dissolve in water, forming a colorless solution. Very important to know that. So when we are going to prepare salts, before you prepare salt, you must know, is this salt I'm preparing soluble or insoluble? Very critical. Another small thing I want to talk about is the solubility of bases. You need to understand that what are the bases? What is a base? When we react a base plus an acid, a neutralization reaction, what are the bases? So metal oxides, or most of the metal oxides are insoluble bases. So a metal oxide is a base, but most of them are insoluble. They don't dissolve in water to form a solution. Soluble bases such as sodium hydroxide, so hydroxides, calcium hydroxide, magnesium hydroxide, all of these ones are called soluble bases. They are the bases. So a base, hydroxides and metal oxides are bases. Very important. It is important to note that. So when we are a neutralization reaction is a reaction between a base and an acid that gives you neutral substances, that is salt and water, as the only products. So having given the basis of the salts, we have defined the salt, we have talked the type of salts, and then we are talking about solubility, that all chlorides are soluble except the one we have said. So we want the basis, or the importance of what we were doing there is this subtopic of methods of preparing salts. So before you prepare salt, you need to understand and be aware is the salt I'm told to prepare soluble or insoluble? So preparing salt depends on the solubility of a salt. It depends on the solubility of a salt. So we have around 7 methods of preparing salts. I want to mention, just mentioning them. We have acid plus metal reaction, which will give us salt plus water. This one is used to prepare acid plus metal, it is salt plus hydrogen gas. So this one is used to prepare soluble salts. If a salt is soluble, and then this method can prepare. I can prepare magnesium chloride. I can prepare zinc chloride here directly because those are soluble salts. Method number 2 is acid plus insoluble base. Insoluble base ni magnesium oxide, copper oxide, copper 2 oxide, lead 2 oxide. So those are insoluble bases. So we will form a salt plus water, and the salts formed here, they are soluble. Number 3, we are going to mention acid plus soluble bases. Soluble bases, mostly they are hydroxides, so they will give a soluble salt. And number 4 is acid plus carbonates. An acid plus a metal carbonate will give you salt, water, and carbon dioxide. The effervescence is expected. Therefore, this one also is used to prepare soluble salts. Number 5, we have acid plus metal hydrogen carbonates. Metal hydrogen carbonates will also give you salt, carbon 4, and water. Therefore, it is a soluble salt. I said I want to just mention methods of preparing salts because my major aim is to show you how to prepare the salts and not. The 6th one is direct synthesis. It can also prepare soluble salt. Direct synthesis can also prepare soluble salts. Direct synthesis can also prepare insoluble salt. Direct synthesis is the direct combination of elements. For example, a metal plus an non-metal, like sodium plus chlorine will give us sodium chloride. So this one is direct synthesis. So this one is soluble. It can also prepare insoluble salt. So direct synthesis, direct combination of elements can prepare both soluble and insoluble salts. And then finally, number 7, this is where my major concern is the precipitation reactions. This one is what we call the double decomposition. It is a type of reaction which occurs, and the salts that are formed here are insoluble. So this is the major method that is used to prepare insoluble salts. Very good. So before we embark on answering the questions, I want you to understand something in the reactivity series. In the reactivity series, we have potassium as the most reactive metal, followed by sodium, calcium, magnesium, aluminium. Then we have an non-metal carbon. So carbon is very reactive than zinc. And then my concern is hydrogen. Hydrogen is more reactive than iron, than lead, than copper, and mercury, silver, and gold. Therefore, what it means, the reason why I'm showing you this is because you cannot react, for example, HCl plus iron to form iron 2 chloride. You cannot react directly lead plus nitric acid to form lead nitrate. If you are asked, starting with lead, describe how to prepare lead nitrate, there is no way you are going to say that add nitric acid to lead. Why? Because lead ions cannot displace the hydrogen here, because lead is less reactive than hydrogen. You understand that? So we are not going to use. Therefore, in this case, you must react lead with oxygen to form lead oxide and then react with nitric acid. Now you must make it an oxide. Very important. Therefore, this reactive series is important for you to understand that all metals that are above hydrogen, you can react with acids directly and form the salts. You can react them with the acids directly and form the salts you want to form. But metals below hydrogen, iron, lead, copper, you cannot react with acids directly to form salts, because the metals cannot displace the hydrogen in the acid, because they are less reactive than hydrogen. You are provided with solid potassium hydrogen carbonate. Describe how a solid or sample of potassium nitrate can be prepared. So we are preparing potassium nitrate. First, ask yourself, is potassium nitrate soluble or insoluble? It is soluble. Therefore, we can react directly nitric acid with potassium hydrogen carbonate to form potassium nitrate. So you start by add excess potassium hydrogen carbonate into a beaker containing dilute nitric 5 acid. Nitric 5 acid. So because you have added potassium hydrogen carbonate in excess, you have to filter so that you can remove the excess. So the next one is to filter to obtain excess potassium hydrogen carbonate as the residue. Another term here we need to understand is the filtrate and the residue. When you are doing filtration, whatever that is remaining in the filter paper is called the residue. The solution that gets over or that goes through the filter paper is what we call the filtrate. So it is important to understand these terms when you are preparing salts. So filter to obtain excess potassium hydrogen carbonate as the residue, and then now we want the solid. So we have now to evaporate the filtrate, which is potassium nitrate. The filtrate is potassium nitrate, of course. So we are going to evaporate that. So evaporate the filtrate to saturation. And allow the saturated solution to cool to form crystals. So by doing this, you would have obtained the solid sample of potassium nitrate. Next one, starting with copper, describe how a pure, mark that, sample of copper 2 carbonate can be prepared. Question 1, you ask yourself, is copper 2 carbonate the salt that you are supposed to prepare soluble or insoluble? Remember, all carbonates are insoluble except potassium carbonate, ammonium carbonate, and sodium carbonate. So since this one is not sodium, it is not potassium, it's not ammonium, it means it is insoluble. So this one is insoluble. So we need to know the method we are going to use. Then obviously we are going to use the double decomposition. So we are starting with lead. We are starting with copper. You cannot react copper directly to get copper 2 carbonate. Therefore, since copper is below the reactivity series, we cannot react copper with hydrogen with nitric acid to form copper 2 nitrate. We need copper 2 nitrate. But you cannot react copper plus nitric acid. Why? In the reactivity series, copper is below hydrogen. Therefore, what we do, you heat this one to form the carbonate. So heat copper metal in air to obtain copper 2 oxide. Very correct. So once now you have copper 2 oxide, now you add warm nitric acid, because actually oxides are insoluble, therefore you need to warm the acid. Next one is to add excess copper 2 oxide to warm dilute nitric acid. This acid could be in a container, in a beaker, so or you can say in a beaker, right? So what have you made? You have made now copper nitrate. We need copper nitrate first. We need that copper nitrate. So since we have in excess copper 2 oxide, we need to filter to obtain the copper nitrate only. So beaker and filter to obtain to obtain copper 2 nitrate. Now we have copper 2 nitrate. What do we do with copper 2 nitrate? Since this one is a solution, since this copper 2 nitrate is a solution, we need a soluble carbonate so that when we react, we mix the two, they will interchange the anions and the cations to form lead, to form copper 2 carbonate. Therefore, we have now the filtrate to obtain this as the filtrate. So next to the filtrate, add sodium carbonate. Remember, sodium carbonate is soluble. Add sodium carbonate solution. Right? Now up to this form, we will precipitate out copper carbonate. To precipitate copper 2 carbonate, copper carbonate, to precipitate copper carbonate. Now the white precipitate will be copper carbonate. Then what do we do? Because we want a solid copper carbonate, we filter the solution. Therefore, next is filter to obtain copper carbonate as the residue, copper carbonate as a residue. Because we were told the pure, you need to wash it. Then wash the residue with distilled water, and then we dry, and then dry and dry between filter paper. So up to that point you have prepared copper 2 carbonate. A sample of water is suspected to contain the sulfate ions. Describe an experiment that can be carried out to determine the presence of the sulfate. I think this question is somehow misplaced because it's not part of the preparation of salts. So, but I can answer that. So, how can we tell somebody that this solution we have contains the sulfate? So, what you do, you add 3 drops of barium nitrate, to, if it is a test tube, to a test tube containing the sample of water that is suspected to contain the sulfate of water. Then followed by about 5 centimeters cube of 2 molar nitric acid, nitric 5 acid. So what would happen if a white PPT precipitate is formed? If a white precipitate is formed, insoluble, which does not dissolve, insoluble in the acid, then sulfate 2 minus sulfate ions are present. That's how you confirm for sulfate ions. A mixture contains ammonium chloride, copper 2 oxide, and sodium chloride. Describe how each of the substances can be obtained from a mixture. Now this is separation, but these are salts. That's why this question is here. Remember, these are salts. So how can you separate this salt? First, you need to understand that which salts are soluble. This one is soluble, this one is insoluble, this one is soluble, but also this one is a supplement. A substance which sublimes, changes directly from a solid to a gas. So how will you separate? I think that's why this question comes here. How can you separate these 3, each of them, to obtain each of them without losing any of them? So let me give you the procedure on what to do. You put this mixture in a beaker. So place the mixture in a beaker. Covered with a watch glass containing cold water. You heat the mixture, until no further change. So what will happen? Ammonium chloride subprimes with subprimes and condenses on the cold water glass. The next, now we are left with copper 2 oxide and sodium chloride, but we know sodium chloride is soluble, copper 2 oxide is insoluble. Therefore, we dissolve this in water. So dissolve the remaining, or add water, or dissolve the remaining mixture in water. You dissolve the remaining mixture in water. So sodium chloride will dissolves, and copper 2 oxide does not. So what do you do next? You filter the mixture to get copper 2 oxide as the residue and sodium chloride as the filtrate. Now next one, now we want to get the solid from the filtrate sodium chloride. You evaporate the filtrate to saturation and allow the saturated solution to form crystals. So these crystals are sodium chloride. You will get them. We have gotten this residue and we have this, and by that we have separated the 3 salts, each of them, without losing any of them. Iron 2 oxide was found to be contaminated with copper 2 sulfate. Describe how a pure sample of iron 2 oxide can be obtained. This one is your home work, so please do that, and if you get a problem you will always consult me. It is always free. I don't charge anything for you to consult me, even if it is at night. I don't charge anything, so you can, if you have a problem, you will always find me. My contacts are always there. Starting with sodium metal, describe how a sample of crystals of sodium hydrogen carbonate may be prepared. We are starting with sodium metal. We want to prepare sodium hydrogen carbonate. So first thing you do, you react sodium metal with water to form sodium hydrogen carbonate. Therefore, react sodium metal with water to obtain sodium hydroxide to obtain sodium hydroxide. So what will you do with the sodium hydroxide obtained? You bubble. Bubble is to pass a gas. Bubble into the solution. Bubble into the solution. Bubble into the solution. Excess carbon 4 oxide gas. Excess carbon 4 oxide gas to obtain sodium hydrogen carbonate. But we are asking to obtain crystals. So after now we have this solution, we need to evaporate. So evaporate the solution. Evaporate the solution to saturation. To form crystals. So once you have evaporated the solution, crystals are going to be formed, and we have obtained the crystals of sodium hydrogen carbonate. Oh, there is 3 here, sorry. There is 3 here, sodium carbonate. Starting with the copper tannings, describe how a sample of copper to sulfate crystals can be prepared. First, we ask ourselves, is copper 2 sulfate soluble or insoluble? Copper 2 sulfate is a soluble salt. The question is, why can't we react Cu plus sulfuric acid to get us copper 2 sulfate? And that story is over. Why can't we do this? The reason is simple. The reason is this. In the reactivity series, hydrogen is above copper, meaning hydrogen is more reactive than copper. There is no way you can react. There is no way copper ions will displace hydrogen in the acid to form the salt you want, because the copper ions is less reactive than hydrogen ion. Therefore, we need to now make this copper to form an oxide. Very important. That is the reason why we can. So you heat copper metal, heat copper metal in air to get copper 2 oxide. Now then you add dilute sulfuric acid. Add dilute sulfuric acid to the copper 2 oxide, to form. So add dilute sulfuric acid to the copper to form copper sulfate. Now we have the copper sulfate. Then what are we going to do with the copper 2 sulfate solution? Filter excess copper 2 oxide and evaporate the filtrate. Evaporate the filtrate to saturation. saturation. Allow the saturated solution, allow the saturated solution to cool and form crystals. Allow to cool to form crystals of copper to sulfate. Form crystals of copper to sulfate. We have prepared that. Quickly, let us look at the next question. Starting with barium nitrate solution, describe how a pure sample of barium carbonate can be prepared. So we are preparing barium carbonate. That's where our interest is, barium carbonate. Question: is barium carbonate soluble or insoluble? It is insoluble. So if it is insoluble, then you must always understand that that one will always involve a double decomposition kind of a reaction. So quickly dissolve sodium carbonate or we are starting with barium nitrate. Okay, so we can start in a different way. Add water not add water. So we have sodium, we have barium. This is the solution we have. So let us add straight. Add barium nitrate. Add barium nitrate solution into a beaker containing sodium carbonate solution. Filter to obtain barium carbonate as a residue. Wash the residue with distilled water and then dry the solid between filter paper, papers. Remember, if we are preparing insoluble salt, we don't evaporate. We don't evaporate to obtain an insoluble salt. Nothing. We only evaporate to obtain crystals of a soluble salt. So what is happening here? We have barium nitrate. We are adding sodium carbonate. So what happens is that the cation this side will take the anion this side, and then the anion this side will take the cation this side, and they will form barium carbonate plus sodium nitrate, like that. And this one is a solid, this one is an aqueous. And this is the white precipitate, and this is the solid we want to form. Describe our sample of lead-2 sulfate, ammonium chloride, and sodium chloride can be obtained from a mixture of the three. That's one is homework. Do that. If any problem, always contact WhatsApp. I will always respond to your problems without any delay. Starting with solid sodium chloride, describe how a pure sample of lead 2 chloride can be prepared. I want also to give this one to you as an homework. This one we have already done it. Let me look at this is the next one. Describe how the following reagents can be used to prepare lead 2 sulfate. So we are preparing lead 2 sulfate, but we have been given as samples. We are starting with solid potassium sulfate. We are starting with lead carbonate, and then dilute nitric acid, and then distilled water. So we have been given the reagents to use. We are preparing lead sulfate. Lead sulfate is insoluble. So if it is insoluble, the reaction is double decomposition. There's no another. If we are preparing an insoluble reaction, we must use the precipitation reaction. We are precipitating out a white precipitate. So first, let us dissolve the potassium sulfate in this water. So dissolve the potassium sulfate in distilled water to form potassium sulfate solution. The next is to react the carbonate with what's carbonate, the react red carbonate with dilute nitric 5 acid to get lead nitrate. Now we have lead nitrate solution and we have potassium sulfate solution. What do? We mix the two solutions. Mix the two solutions. Mix the potassium sulfate solution and lead nitrate solution to precipitate lead sulfate, The next one now, since we have formed lead sulfate, which is an insoluble salt, we filter to obtain the mixture. Filter the mixture to do what? To obtain lead sulfate as the residue, and as the residue. Then what is next? Because we wanted is pure, we have used to prepare the 2 sulfate, so there is no need of washing. We can leave at that point. So filter the mixture to obtain lead sulfate as the residue, and that is all. We stop at that point. If we are asked that to prepare pure, we need to wash it. If we were asked to give a dry solid, we need to dry it, but here we are not asked to dry it, so we can stop there. You are provided with water, lead carbonate, dilute nitric acid, solid sodium chloride. Describe a very clear step by step on how to prepare lead chloride. Homework. Do it and I will mark for you. No problem. Thank you for your time.